जी भाई, you're still.
Non-viscous.
I'm asking, viscous liquid is always viscous. We are talking about the liquid. Insulating liquids. If liquid is conducting, then obviously your capacitance won't work. Both the electrode will get shorted. Am I right?
Yes.
So the scheme which I'm discussing setup I am discussing here, it is only suitable for the uh, non-conducting, means insulating liquids. If your liquid is conducting, then obviously your capacitance, your both the electrodes will get shorted, and it won't work. And you must have studied cable, capacitance of the cable between sheath and the core. The same formula used here. So the capacitance is equal to liquid permittivity and the liquid height plus vapor, the empty part. Here you see we are calling it vapor here, and then liquid. Vapor means air here. So, and this is the outer electrode radius, and this is the inner electrode radius. So this is how, uh, and here it is measured. It is means this formula is came with the assumption that height is much more than the radius or difference of radius. So this is how, in this case, everything is constant except the liquid level. You can see. So as the liquid level will vary, capacitance will vary, and you can see that it is a straight line equation also. It is a straight line. Now, in this case, we can improve upon this by having a, if rather we can say it like this: if the tank is metallic, if tank is metallic, then this tank may work as a outer cylinder of the capacitive sensor, and then we require only one electrode, thin electrode. So here in this case, you see your tank is made up of metallic material, and it is grounded also. So this is basically, this will work as a outer electrode, and then we require a thin solid electrode. So obviously a capacitance formation will take place between this inner electrode and this tank working as a outer electrode. So this here you can see that we are having two terminals. One of the terminal is connected to the tank, and another terminal is connected to the central electrode, inner electrode. And then you can see that, like, again in this case also, this setup is also, it will work only for the non-conducting liquid, means insulating liquid. So in this case, so this is the liquid resistance, and as far as the equivalent circuit is concerned, this is your liquid capacitance. At the liquid level will vary, this capacitance will vary. And similarly, this is air capacitance. So this will also vary as the your air level, your liquid level go up and down, and so air level will, the part filled with the air will also vary. It will become less and more, increase or decrease. So this is what is your liquid level and your air height. So equivalent circuit, you can see that this is the equivalent circuit. These two capacitance are the variable capacitance. This is for the air, this is for the liquid level, and this is your cork, this cork capacitance, means you can see that this cork is insulating material, and then these two are electrodes, so it will also, but the value will be constant, and this is your resistance of the insulating material, and this is for C2 is for the liquid. So if you look upon this R we can make assume as a open, because the because of the um, insulating liquid, so its resistance will be very high, so we can assume it as a open. So when we are taking it as an open circuit, so equivalent capacitance will be C0 C1 plus C2. So that's what written here. Then we have written equation for C1 and C2. Here you can see that it's the same equation as you see this equation only, because your electrode, your setup remains same. Only thing is that here we are using tank as a electrode, outer electrode. Now I'm trying to reconfigure this expression in a meaningful form. So in this case also, if you look upon this, so this term is constant, this term is constant, only this term is varying. All other means parameters which are here, they are constant. Only HL will vary. Now what I did, this I added here plus HL. We have added HL. So here we added. So obviously we have to subtract also. So whole term is subtracted. So here we added HL with the epsilon V. So here we subtracted HL with the epsilon V. So here you can see that so HL plus HV will be total height of the tank. So here you can see that we have taken H, and so if you look upon this expression, so this whole term is constant. You see, this whole term is constant. I'm sorry, this HV is not constant here. So to make it simple, this whole term is constant, and only this term is varying. So this is basically a straight line equation that we always desire. So this is a constant term. This is your slope. Remaining part is slope, and HL is your another variable, independent variable. So this is how you can see that this setup can be represented. So if anybody is having any question regarding these two setups that I try to explain for measurement of liquid level in a tank, you can ask please. This method is very accurate method, and it is widely used in many cases, especially in vehicles and in aeroplane. Mostly capacitive technique is used for fuel level measurement. जी कोई क्वेश्चन है आपका? How many of you
सर
joined?
थर्ड टर्म कैसे आया?
जी बताइए क्या कह रहे हैं?
सर सी में जो थर्ड टर्म आपने यूज किया है वो कैसे आया?
क्या चीज?
ई एल माइनस ई वी इंटू एच एल बाई 2 log ई डी अपन डी, वो कैसे आया सर?
ये
यस सर, थर्ड टर्म।
भाई आपने, ये हमारा एक्सप्रेशन है ना, तो इसमें हमने एच वी ऐड, रादर एच वी नहीं ऐड किया हमने, एप्सिलॉन वी एच वी अपॉन 2 log ई डी अपॉन डी ऐड किया, ठीक है ना?
हाँ यस सर।
तो उतना ही सब्ट्रैक्ट कर दिया।
ओके।
तो उसको एक एप्सिलॉन वी एच वी 2 log ई डी अपॉन डी को इसके साथ ऐड कर दिया, और सब्ट्रैक्ट वाले को इसके साथ क्लब कर दिया, प्लस को इसके साथ क्लब कर दिया, माइनस को इसके साथ क्लब कर दिया, ठीक है?
हाँ यस सर, थैंक यू।
समझ में आ गई बात?
यस सर।
Okay. Any other thing? Anything else? Anyway, now if we want to measure the with this setup, with this setup, if we want to measure the liquid level for the uh, conducting fluid, then this is the one of the suggestion. This is we should insulate the inner electrode, and then your equivalent circuit will be something like this. In this case also, the equivalent capacitance, although things are bit complex, but anyway, your capacitance will vary as the liquid level will vary, and by measuring the capacitance, we can measure the liquid level. So this is the uh, option setup for the conducting fluid. Then for very high conducting fluids, this is one of the method that is not exactly similar to somebody who told, but it is very close to that. In this case, you see, and this is valid only for the um, highly conducting fluid. So in this case, we are having two capacitor plates here, and then above the tank, and we are applying, and tank is obviously conducting in this case, and it is grounded. So we are applying the capacitance across um, uh, the tank and this whole setup, you can see. And your liquid level, the surface of the liquid will work as a one of the capacitance electrode. So here basically there is a formation of capacitive voltage divider. One capacitance is getting formed between plate A and B, your electrode plates. Another capacitance is getting formed between B and the surface of the conducting, highly conducting fluid. So as the conducting your fluid liquid level will go up and down, obviously this capacitance C2 will vary. And by measuring the voltage across this capacitance, we can find out the liquid level. So this, you can see that this voltage is basically determined between the means across the C2, that is a variable capacitance. And voltage divider formula, V naught is equal to C1 upon C1 plus C2 into V, because it is 1 upon omega C2. So because of that, so in this case, but you see, as the C2 will vary, C1 is constant, your applied voltage is constant. As the C2 will vary, accordingly your voltage will vary. But this scheme will work only in the case when your um, liquid is highly conducting. Otherwise, you won't find any change as the liquid level. So this is a kind of capacitive technique for liquid level measurement, non-invasive type, non-invasive. That means you are not putting anything inside the tank, liquid inside the liquid and inside the tank. So this is what how this voltage varies with the capacitance. Now there is a one method, that is ultrasonic method. Ultrasonic sensors are basically acoustic sensors of very high frequency, and in this case, it's very cheap and very simple and very good method. In this case, your ultras means this is your ultrasonic transmitter and detector, and ultrasonic waves are transmitted, and when it basically reaches to the liquid level, and then it is reflected back from the liquid level, and um, time measurement is done, that how much time it is taking in going to the liquid level after means it's release from here, and then getting back. So that is called echo. So this is basically ultrasonic means transmitter and detector together pair. It is around 100, rupees. It is available in the market. So it is very simple also, and it comes with along with the with the uh, signal conditioning circuit, that when it is released, then you get a trigger pulse, and when it is receiving the echo, then you will get the trigger pulse at the echo terminal. There are three terminals. So so you are required to find out the time between the initial pulse and the echo pulse. And obviously, this we are interested in finding out the distance, so that we know the speed of the ultrasonic signal, and we divide the ultrason sorry we multiply the ultrasonic signal with the time speed of the signal, then we'll get the distance, how much distance it is traveled. And by finding that distance, we can find out, because you know the total height of the tank. So you, basically time is directly proportional to HL. So you will subtract it with the total height, then you will get the. So this is how it is done. This is, you can see that the time is proportional to H minus H. So this is how, and it is very simple. It is very easy and very accurate also. It works. And in this case, it is immaterial whether your liquid is conducting or your liquid is non-conducting, or it is a solid. Means, if even if your tank is having something solid or sludge is there, that is immaterial. So this is a very good method and non-invasive method. You are not required to disturb anything in the tank. You are not required to insert anything. So this is how measurement is done with the ultrasonic. Ultrasonic sensors are very popular nowadays, many applications ultrasonic, because most of the time you'll find it is basically the non invasive type. And so this is your ultrasonic. Now I'm coming to the inductive sensor. This is one of the very popular inductive sensor, linear variable differential transducer. It is called transducer, and it is also T stands for. So it is, in short, it is called LVDT. LVDT stands for linear variable differential transducer or transformer. Basically, it is in the from by construction. Although it is a sensor, but transducer or sensor, but by construction it is a transformer. So that's why T is also used as a transformer. So it is a passive inductive transducer, and it is used for measurement of displacement. Means it is used for displacement measurement. So you can see that the diagram of this transducer. Here in this case, this is your primary winding, and it is having one single primary winding, but the two identical secondary winding, um, and these two secondary windings are connected in series opposition. Series opposition means the output voltage will be difference of these two voltages. Whatever voltages that will get induced in this secondary identical secondary winding, the output will be the they are so connected. So it will be, they will be connected in series opposition. So the output will be difference of these two voltages. Now, setup is like that. Your windings are wound on a uh, hollow bobbin, hollow cylinder, and inside the cylinder there is a core, and this core is movable. So obviously, when you will move the core, then flux linkage of these two windings will get affected. But when your core is in center, when the core is in center, so in that case, this is called a reference position. In that case, your ES1 will be equal to ES2, and your output will be 0. Your output will be 0. Now, if you'll move the core this side, so obviously your ES2 will become more than ES1, because here will flux reluctance will be less, so the more flux linkage will take place, and here your reluctance will be high and less flux linkage will take place. So obviously this will become non-zero, output will become non-zero, and in this case it will be for the given connection it will be negative also. It will be finite and it will be less than, it means it will have negative sign. Now other way around, if your core is moving in this direction from the reference position I'm talking, so in that case your flux linkage of this coil will increase in comparison to this, then es1 will become greater than es2, and your voltage will become finite output voltage and it will be positive also. So this is the situation how, so this, the whatever displacement we want to measure, that will be with that displacement we'll displace the core from the reference position, and then accordingly we'll get some output. This output is proportional to the displacement, one thing. Second thing is that it also tells, not only it converts the displacement into the voltage, it also tells that what is the direction of the motion with respect to the your reference position, whether it is the left side or the right side. So in this case you can see that basically we call it phase, means at the output voltage you are having a magnitude as well as phase. So magnitude gives you the amount of displacement, and the phase tells you the direction of the displacement. Okay to all of you? Yes, please. This is how your LVDT works. Here in this case, whatever I explained, I tried to show here. You can see that as the your core moves in one direction, so this is how your voltage will increase, and if in the other direction, then the polarity will change, and this is how, and there is a saturation. Obviously when your core is going out of the catchment area of the primary and secondary winding, or out of cylinder, then it will diminish, because in both the windings your flux linkage will diminish. This is how it works. Then certain specifications I had shown so that you should have idea. um, the sensitivity is high in this case. Generally sensitivity is high. It is 50 millivolt per millimeter to 300 millivolt, so it is a good sensitivity as far as the um, measurement sensor sensitivity, instrumentation system sensitivity is concerned. So it is a very good sensitivity. And ranges you can see, because the sensitivity is good, so very small displacement we can measure. So you can see that zero point 0.05 inch to plus minus 25 inch. Obviously if you are going for the larger displacement measurement, then the size of your LVDT will also increase. So here you can see that we can measure up to 0.05 inch. It's very small because of the good sensitivity. LVDT can be, and then other thing is that depending upon the material, it can work at the lower. It's a very robust kind of sensor. It's not very sensitive, so it can work in the extreme conditions also, provided you are having suitable kind of material to make the. So this is all about your. Now I want that all of you should solve this problem. This problem is very simple, common sense problem, and I want that all of you should solve. And by the time I'll take your attendance. Respond your roll call, please. Roll number 1, 2, 3.
Present, sir. Roll number 2.
Roll number 2 is present.
Yes, sir.
Farhan?
Yes, sir. Yes, sir.
Okay. 3. Mohammad Arshad Faizi. 4,
Present, sir. Roll number 4.
5, 6,
Present, sir. Roll number 6.
7, 8, 9, 10, 11, 12, 13,
Present, sir.
14,
Yes, sir.
15, 16, 17, 18,
Yes, sir. 18 present.
19,
Present, sir. 19.
20, 21, 22, 23, 24, 25, 26,
26 present, sir.
27, 28, 29, 30.
Sir, roll number 3. 5, sir.
You're sure?
Yes, sir. Roll number 5.
Okay. Anybody
Roll number
else?
7, sir.
7. Okay. Anybody else? On the first page, 1 to 30.
Roll number 7, sir.
7, I marked you. Now, 31, 32, 33.
Present, sir. Roll number 33.
33 is present.
Yes, sir. Present.
35,
Present, sir. 35.
36,
Yes, sir, 36.
37, 38,
Present, sir. 38.
30, 40, 42, 43, 44, 45, 46, 47, 48,
Sir, 46.
46, okay, 48, 49,
Present, sir. 49.
50, 51, 52, roll number 52, 53, 54, 55, 56,
Present, sir. 56.
okay, 57,
Present, sir. 57.
58, 59, 60, roll number 60, 61, 62. Anybody from roll number 31 to 62? Anybody else?
Sir, 32.
32.
Muhammad
Okay.
Arif, sir.
Okay. Anybody else? 63, roll number 63, 65,
Present, sir.
66, 67, 68,
Present, sir. Roll number 68.
okay, 69, 70, 71, 72, 73,
Sir, 69.
60,
69.
okay, 73, 74, 75, 76, roll number 76, 77, 78,
Present, sir. 78.
79, 80. Bashir Alam.
Present, sir. Bashir Alam.
Anybody else? Anybody else on the last page? 60.
23, sir. Roll number.
23.
Yes, sir.
Anybody else? Okay. This problem is having two parts. In first part, the output of an LVDT is connected to a 5-volt voltmeter through an amplifier whose amplification factor gain is given. An output of 2 millivolt appears across the terminals of the LVDT when core moves through a distance of 0.5 millimeter. So in first part, you are required to calculate the sensitivity. Calculate the sensitivity. तो sensitivity बताइए किसने किसने calculate की? Sensitivity बताइए. हाँ भाई. Sensitivity बताइए. Sensitivity का क्या formula होता है? You know, many times you people told me. Sensitivity का क्या formula होता है?
Output upon.
हाँ, तो आपका जो आउटपुट चेंज हुआ है, it is change from 0 to 2 millivolt and input from 0 to 0.5 millimeter. So tell me the sensitivity. 0.5 upon 2 millivolt. So sensitivity of LVDT will be this, volt per millimeter or millivolt per millimeter. 0.25 millimeter per, it will be 4 millivolt per millimeter. Is it fine?
Yes, sir.
Now this is the sensitivity of your LVDT. What will be the sensitivity of the whole instrumentation system? Means LVDT as well as amplifier, because your output is getting amplified by 250 times. Then how much will be the sensitivity? कितना हो जाएगा? तो कॉमन सेंस की प्रॉब्लम है भाई, इसमें कोई इंस्ट्रूमेंटेशन नहीं है. आपको खटाखट बताना चाहिए. इस टाइप की प्रॉब्लम्स ऑब्जेक्टिव क्वेश्चंस आते हैं आपके कंपटीशन में. ये तो ऑब्जेक्टिव क्वेश्चन है. जो फर्स्ट पार्ट है दैट इज ऑब्जेक्टिव क्वेश्चन.
जो एम्प्लीफिकेशन फैक्टर है वही हो.
चाहे आप सेंसिटिविटी को एम्पलीफाई कर लीजिए और चाहे वोल्टेज को एम्पलीफाई करके सेंसिटिविटी कैलकुलेट कर लीजिए. भाई आउटपुट now your output is the output of the amplifier. So for this displacement, how much will be the output of the amplifier? अगर आपने LVDT के आउटपुट में एक 250 गेन का, तो सिंपल चीज है, आप कोई बता ही नहीं रहा. ये आपका LVDT है, इनपुट इज डिस्प्लेसमेंट, आउटपुट जो है वो कुछ वोल्ट मिल रहा है आपको, उसको फिर आपने एम्पलीफायर में डाल दिया जिसका गेन है 250. तो आउटपुट कितना हुआ? ये हम क्वेश्चन, यही है क्वेश्चन. आपने अभी सेंसिटिविटी इस स्टेज की निकाली, इस स्टेज की सेंसिटिविटी निकाली. अब पूरे दोनों इसकी पूरे की सेंसिटिविटी निकालने को कहा जाता है.
250 into sensitivity of LVDT.
50
सर
क्या
1000 हो जाएगा.
क्या हो जाएगा?
1000 250 into
1000
4
1000 क्या कोई यूनिट है?
सर वोल्ट पर मीटर
1000 वोल्ट नहीं होगा, 1 वोल्ट होगा, 1000 मिली वोल्ट होगा, 1 वोल्ट पर मिलीमीटर, है ना। यहाँ पे जब आप 0.5 से डिस्प्लेस कर रहे थे तो आउटपुट आपको मिल रहा था corresponding to this, you was getting 2 millivolt here, 2 millivolt, and उसको 2 मिलीवोल्ट को जब एम्पलीफाई करेंगे तो कितना हो जाएगा? 500 मिलीवोल्ट। 250 टाइम्स हमने इसको गेन है हमारा, तो 250 टाइम्स हमने वो किया तो इट विल बी 500 मिलीवोल्ट। और सेंसिटिविटी के लिए इसको 0.5 से डिवाइड करेंगे, 0.5 मिलीमीटर से, तो इट विल बिकम 1000 मिलीवोल्ट्स, दैट इज इक्वल टू 1 वोल्ट। ठीक है भाई, किसी को नहीं समझ में आया तो पूछ लीजिए। अब व्हाट अबाउट सेकंड पार्ट? Now the second part, the voltmeter scale क्या है? The voltmeter scale means here a voltmeter is connected. Suppose here or here a voltmeter is connected. So the voltmeter scale has 100 division. This voltmeter is having 100 division. The scale can be read up to 1/5 of a division. This is very important. Means fundamental. Means you require a very fundamental concept to solve this part. And it is many times this kind of problem, many times I had seen this is type of problem. Objective questions, a lot of objective questions are asked. So the voltmeter scale has 100 divisions and the scale can read up to 1/5 of a division. Calculate the resolution of the instrument in millimeter. What is resolution? Resolution. Resolution. Yes, please. What is resolution? ये कैलकुलेट करना है, तो जब तक रेजोल्यूशन के बारे में आपको मालूम नहीं होगा तो आप हाउ विल यू कैलकुलेट? यू मस्ट हैव स्टडीड दिस टर्म इन योर प्रीवियस कोर्स. रेजोल्यूशन क्या होता है भाई? For any instrument, resolution is one of the specification, characteristic parameter, like sensitivity and range, calibration expression, बताइए, linearity, all these things are basically characteristic parameter of a instrumentation system. Resolution क्या होता है? कोई भी idea हो, I'm not saying that if you are having some idea, some guess, although you must have taught in first unit of your, along with the sensitivity and other parameters, characteristic parameters. किसी को नहीं आता?
सर रिजोल्यूशन की जो वैल्यू होगी, अगर उतने से हम इंस्ट्रूमेंट की पैरामीटर को चेंज कर देंगे तो हमारा डिजायर्ड वैल्यू होगा.
डिजायर्ड नहीं, दिस इज द मिनिमम डिटेक्टेबल चेंज इन इनपुट. मिनिमम detectable change in input means if this is a change actually, not from the zero value. If suppose certain value like 0.5 millimeter at displaced, now from this 0.5 if I am moving the core, then there will be certain minimum increment. after which you will get some measurable detectable output on the voltmeter. You understanding what I'm saying? So this minimum change in the input that will be detected at the output side, means give you the measurable change at the output side, it is called basically the resolution. This is called, so minimum detectable change in input is called resolution, and minimum detectable input is called threshold. When we are increasing it from the zero value, then that is called threshold. So this minimum detectable change in input, minimum detectable or measurable change in input is called basically the resolution of any instrumentation system. तो ये कैसे कैसे मालूम करेंगे, इसीलिए कहा कि रेजोल्यूशन इन मिलीमीटर में मालूम. तो which, now you are having a description of whole setup. Now which thing will decide the minimum measurable change in this setup? बताइए. भाई, minimum voltage we can measure up to 1/5 of a division. 1/5 of a division. So obviously if there is any change, it should be equivalent to 1/5. It should make a change of 1/5 of a division. Only then this meter can detect, because this meter minimum detection capability will decide the resolution of this whole system. So we'll go from outside to inside. First of all, we'll try to find out how much is the, in terms of the voltage, because there are 100 divisions, and you see this is the 100 division, and the full scale value is 5 volt. So 100 division is indicating 5 volts. So 1/5 of a division is indicating how much voltage, and that voltage is basically means that voltage is representing what change in the displacement. So that's what we will. So here you see, so LVDT, you can see that the LVDT sensitivity is calculated. It is 4 millivolt per millimeter, and the amplification for instrument, it is amplification factor into the sensitivity, the LVDT. So it is coming out to be 1000 millivolt per millimeter or 1 volt per millimeter. Now I'm coming to the second part. One scale division is equivalent to 50 millivolt. 5 volt divided by 100 divisions. So 1 volt, one scale division is equal to the 50 milli. It indicates 50 millivolt. Now 1/5 of it obviously will indicate, 1/5 of a one division will indicate, this is further divided into 5 parts. It is like that. So it is equal to 10 millivolt. Now 10 millivolt represents how much displacement. Will divide it 10 millivolt by the sensitivity, by the instrument sensitivity. So we'll get the displacement. So 10 millivolt represents 10 into 10 power minus 3 millimeter displacement. So this will be the resolution of the instrument. So if anybody is having any question regarding it, many times this kind of question is asked in the competitive exams as an objective question, as far as the second part is concerned. It is a very basic conceptual question. So if anybody is having any question regarding this part or any part, this problem, that solution is in front of you. If you are not clear about any of these things, you can ask please. Anyway, so this is the up to this means I plan to discuss today, not today, in this unit you can say. So this today I am closing this unit, that is basically the sensor unit, that with different type of sensors we have discussed, and only these sensors are in your course, although the sensors, there are numerous sensors, and they are having, even whatever sensors we have discussed in this unit, they are having many applications. They can be used for measurement of. It is only your knowledge of the sensors. Now if you have been told to to design an instrumentation system for the measurement of particular parameter, then with the knowledge of these sensors you should try to build up a instrumentation system. That is what is done. So I'm closing my this unit here, and I'm starting the fresh unit number 4. And unit number 4 is about your electronic instrumentation and um, and magnetic measurement. So I'm starting with the electronic instrumentation. um, Anyway, today I'll start with the magnetic measurement, then we'll take up the. So magnetic measurement, like uh, other parameters, magnetic parameters measurement is also a challenge, and it is desirable also. So we'll discuss many things. Starting with the separation of iron loss. You must have studied in detail iron loss. Uh, what are the two components of the iron loss?
Sir, eddy current loss and hysteresis loss.
G.
Eddy current loss and
AD
hysteresis
current
loss.
loss and hysteresis loss. You must have studied all these losses in detail in your machine subject. So
Yes, electrical machines.
electrical machines, and I don't know, because of the pandemic you may not be able to perform the experiments, but you should have knowledge of in transformers, the open circuit test and short circuit test. नॉलेज तो होगी भाई ओपन सर्किट टेस्ट की और शॉर्ट सर्किट टेस्ट की.
Yes, sir.
तो जो ओपन सर्किट टेस्ट करते हैं हम, उसमें जो वॉटमीटर की रीडिंग होती है वो किस चीज के बराबर होती है?
Sir, core loss.
कोर लॉस. आयरन लॉस और कोर लॉस में क्या डिफरेंस है?
Sir, iron loss is a constant loss and core loss is directly proportional to a square of
कॉपर लॉस क्या होता है?
oh no, sir, copper loss. Square of a current copper loss. Core loss.
कॉपर लॉस होता है वो. तो कोर लॉस क्या होता है? आप लोग थर्ड ईयर में पहुंच गए भाई, है ना? And you people, most of the people are silent. They don't have any opinion about anything, and those who are speaking uh, means they are also having a very uh, poor knowledge of the fundamentals. Core loss and iron loss, same thing. Core loss and iron loss is same thing. Either you call iron loss or core loss, it is the same thing.
Sir, ये शायद से मैग्नेटिक कोर में होता है. अल्टरनेटिंग करंट के अल्टरनेटिंग अल्टरनेटिंग करंट की वजह से.
हाँ, मतलब ये मैग्नेटिक लॉसेस हैं, कोर लॉस और आयरन लॉस. और you must have, means it occurs in a magnetic core. And hysteresis loss, what is hysteresis loss then? What is hysteresis loss? You should have good knowledge of all these things. If you are not having, then, and generally in machine paper it is taught in detail. In physics also it is taught. Hysteresis loop देखा है? Hysteresis loop.
Yes, sir. Yes.
है ना? So this basically, as far as the physics behind it is concerned, when you magnetize a material, because when you are having a AC excitation, then you magnetize the material, then you demagnetize it, then you remagnetize it in another direction. So certain work done takes place, and this work done is basically your hysteresis loss, and it is proportional to the area of the hysteresis loop. If certain material is having thick area, so its loss, it will be having more hysteresis loss, and if it is thin, then it will be less hysteresis. So suitable means at the 50 hertz power frequency, we use suitable material which is having thin hysteresis loop. So for transformer, which material is used? Can you tell me? At 50 hertz at power frequency, आपने जरूर पढ़ा होगा जब आपको ट्रांसफार्मर पढ़ाया गया होगा. सिलिकॉन स्टील यूज करते हैं ना, CRGO, कोल्ड रोल्ड ग्रेन ओरिएंटेड सिलिकॉन स्टील. इट्स hysteresis का loop is thin. बात समझ में आई?
Yes,
Yes,
sir.
sir.
Can you repeat the formula? Silicon steel क्या?
CRGO, silicon steel. CRGO means cold rolled grain oriented. This is basically heat treatment. Heat treatment is done on the material to produce the desirable properties, है ना? जैसे
Okay,
गाड़ियां
sir.
बनाई
Thank you.
जाती हैं, गाड़ियां, आप कभी कार के प्लांट में जाएंगे तो आपको एक बड़ा सेक्शन मिलेगा जहाँ पे हीट ट्रीटमेंट होता रहता है. डिफरेंट पार्ट्स को हीट ट्रीट करते हैं, कहीं कहीं पे उसको फर्नेस में गर्म करके फिर उसको ऑयल में क्वेंच करते हैं, मेनी मेनी. सो similarly, this cold rolled grain orientation is also a heat treatment, a mechanical treatment of the material, और मटेरियल का नाम है सिलिकॉन स्टील. तो ये आपने मशीन किताब में जरूर पढ़ा होगा. और जब फ्रीक्वेंसी बढ़ जाती है, अगर हायर फ्रीक्वेंसी पे आप काम कर रहे हैं, तो ऑब्वियसली ये मटेरियल नहीं यूज करते हैं सिलिकॉन स्टील. वी गो फॉर द फेराइट्स. फेराइट कोर्स मार्केट में मिलते हैं, जो इलेक्ट्रॉनिक सर्किट वगैरह में हाई फ्रीक्वेंसी पे काम होता है, तो उसमें हम फेराइट कोर्स, सिलिकॉन स्टील नहीं यूज की जाती है. ठीक है. अच्छा, एडी करंट लॉस क्या होता है? एडीज जानते हैं? एडीज
शॉर्ट सर्किट लूप्स सर.
क्या है? शॉर्ट सर्किट
लूप्स inside a material.
बहुत
The losses that occur because of नॉन एक्सपेंसिव, मतलब सर वायर्स का जो कोटिंग होता है, जो मतलब सर इनएक्सपेंसिव होता है, उसके चलते जो लॉसेस होते हैं उसको एडी करंट लॉसेस बोलते हैं.
हमने पूछा
वो
एडीज
सर
जानते हो? हमने पूछा एडीज जानते हो?
नो नो सर, एडी नहीं जानते.
तब तो फिर तुम एडी करंट जानोगे भी नहीं. पानी में कभी पत्थर फेंका है? पॉन्ड में नहीं फेंका, वो भी नहीं किया. पढ़ाई भी नहीं
नहीं
करते,
देखा है सर.
पढ़ाई भी नहीं करते हो, पत्थर भी नहीं फेंकते हो.
सर फेंकते सर, लेकिन वो नीचे चला जाता है.
नीचे चला जाता है. होता क्या पानी में? कुछ पैटर्न बनते हैं गोल गोल.
यस सर, वेव्स
दे आर कॉल्ड
क्रेस्ट एंड
एडीज.
ट्रफ्स
दे
बनते
आर
हैं.
कॉल्ड
क्रेस्ट
एडीज.
एंड ट्रफ.
They are
यस.
called ADs. So when we magnetize the means core, then EMF is induced because of the Faraday's law in the core also, and because of that, current flows in form of ADs in the across the cross section of the core. है ना? ये कोर का क्रॉस सेक्शन है. अगर आपका
ओके सर.
ये जो कोर का सपोज करो क्रॉस सेक्शन है, स्टेप्ड होता है. मैं चलो स्क्वायर ले रहा हूँ, ऑल्दो स्टेप्ड होता है ये. तो इसमें ये करंट ऐसे फ्लो करता है बिकॉज ऑफ द फ्लक्स लिंकेज. तो ऑब्वियसली करंट फ्लो करेंगी तो इस पाथ का कुछ रेजिस्टेंस होगा, तो इसमें आई स्क्वायर आर लॉस होगा. करंट इज एडी करंट, आई स्क्वायर आर. सो दिस लॉस इज कॉल्ड एडी करंट लॉस. तो इससे ही आपका कोर हीट अप होगा, है ना, लॉसेस होंगे. तो इसको कम करने के लिए क्या करते हैं?
सर लेमिनेट करते हैं इसको।
लैमिनेशंस करते हैं, तो लैमिनेट करेंगे तो ये लैमिनेशंस यूं हो जाएंगे, तो उसकी वजह से क्रॉस सेक्शनल एरिया कम हो जाएगा। जब क्रॉस सेक्शनल एरिया कम होगा तो क्या होगा, है
सर
लैमिनेशन।
एडी करंट लेस फ्लो करेगा।
क्यों?
सर
लूप
क्रॉस
लूप
सेक्शन
की वजह
एरिया,
से
क्योंकि
फ्लो
सर
कर रहा है।
current is dependent on resistance, and resistance is inversely proportional to
Correct,
area
correct.
of cross section.
So your eddy current path resistance will increase, and accordingly your eddy current will be reduced. So only eddy current will be confined here. So laminated cores are used for. Anyway, few things I just want to make you understand, or revise rather, you can say. Now here, as far as this topic is concerned, here anyway, I'll start. It is already late. You have to catch another class. So I'm closing my today's lecture here. So we'll start this on the next. Thank you.